Children, in the last lecture, you have learned about another colligative property named depression of freezing point. I'm sure now you remember that these colligative properties are dependent on number of moles of solute dissolved in definite amount of solvent and not upon their nature. Do you remember the graphical representation of the last lecture in which variation of vapor pressure with temperature for a pure solvent, solution 1 and solution 2 was discussed? So what is the inference drawn? That as much solute we add in a solvent, there is that much depression of freezing point observed in the solution. That is, look here, depression in freezing point is directly proportional to the lowering of the vapor pressure. Now let's see expression for depression of freezing point. Actually, it is quite similar as you have already learned for elevation of boiling point. Now let's begin it. Let's see. This is the Raoult's law. I hope you remember. You have done it earlier. This is the expression for Raoult's law for dilute solutions. Now see, if we transform this particular formula we get here, this is the lowering of the vapor pressure equals capital P M small w small m and capital W. You all know what is what. Since vapor pressure P and the molecular mass M is constant for particular solvent, because this is what? P is the vapor pressure of pure solvent at a given temperature. So this P and capital M is constant for a solvent. Now see, what is this? Small w upon M, capital W. Small w is weight of solute, M is molecular mass of the solute, and if W, capital W is 1 kg, we get it as this expression, right? Now since delta P is directly proportional to delta TF, what is delta TF? This is the depression of freezing point. So I can consider it delta TF is directly proportional to this particular. That is what? That is the number of moles dissolved in the solvent, which is 1 kg. Now this W upon M multiplied by capital W represents the molality of solution. And what is that? 1 mole of the solute dissolved 1 kg. Let's see here. W by M is 1 mole and capital W is 1 kg. Now look here. This delta TF, that is the depression in the freezing point, is directly proportional to the molality. This M dash is molality. Now we make it more simple. So here this Kf is the molar depression constant. This is directly proportional. So this is Kf is the proportionality constant, which is being named as molar depression constant or cryoscopic constant. Now again, the same expression I would like to consider if this molality is what? Here. If 1 mole W by M is present in 1 kg, so molality becomes what? 1 molar. So delta TF equals this Kf. And what is this Kf? It is a constant, cryoscopic constant. What is this delta TF? This is the depression in the freezing point. Thus, molar depression constant, that is this Kf, is equal to the depression of freezing point produced by 1 molar solution. This is the one equation we have derived here. Now let's see determination of relative molecular mass of a solute on the basis of depression of freezing point. Let's see again. This we have already done in elevation of the boiling point, but still we shall do it again and it is going to be like a revision. Molality is equal to what? Number of moles of solute upon mass of solvent in kg, which I have expressed it in this form. Now again the molality, it is being expressed more clearly. Now putting this molality expression in equation 3. Where is equation 3? Here. See, this is the equation 3. Now on putting this expression of molality in equation 3, we are getting the expression here. On transforming this expression, I am getting the molecular mass. This is M stands for molecular mass here of the solute. Molecular mass equals 1000 kF small w delta T FW. You know now, up till now, I think you remember now what is this kF. kF is the molar depression constant, kF, or cryoscopic constant. What is delta TF? It is the depression in freezing point. That is, this is a difference between the freezing point of the liquid and the freezing point of the solution, which is obviously less than the freezing point of the pure solvent. What is this W? W, it's already written here. It is the weight of solvent in grams, and this is small w, weight of solute in grams. Children, we know